welcome. Would be great if some more would join us, but I hope maybe later. So welcome to the side event on the ocean and planetary boundaries, unlocking a deeper vision for the Earth's future. Long title, important topic. So I'm Kirsten Inde from the Intergovernmental Oceanographic Commission of UNESCO. They're in the Ocean Science section, and we organized this event with many other partners. You see the logos here as well. It's SOLAS, the Global Ocean Oxygen Decade Program, the Ocean Acidification Research for Sustainability Program, OASIS, another Ocean Decade Program, GOOSE. We heard already a lot about observation beforehand, and of course, Mercator Ocean International. So why are we here tonight? Science is needed, but understanding the science is even more needed, and communicating the science. And the planetary boundary framework provides an avenue for communicating this much better. In the planetary boundary concept, we have 9 critical environmental thresholds that humanity must not exceed to maintain stability and support life. However, within these 9 planetary boundaries, only one is dedicated to the ocean and emphasizing the critical consequences for its central role in regulating Earth's climate, focusing specifically on aspects of the ocean's visible zone. What we propose here in this only 75 minutes side event, so we have to be all very sharp and on time, and I'm trying my best, is really that we try to challenge a little bit participants in how to extend the planetary boundaries framework into the ocean's interior and all its domains from physics to biogeochemistry and biodiversity, having a more holistic approach on it. And so that we are really well representing the ocean functioning and habitability of the planet in general. So without further ado, I will actually hand over to a video keynote by Johan Rockström, who's director of the Potsdam Institute for Climate Impact Research, and he's really he developed the planetary boundary framework, and I'm very happy that we have, that's me, that we have Johan Rockström giving a short video.
Dear colleagues, friends, this is an opportunity to give you a scientific update of the latest challenges in terms of risks posed to the stability of the entire planet. For the first time, we are forced to address the key question, are we at risk of destabilizing the life support, the functioning, and the resilience of the Earth system? We also know that the ocean system is ultimately the determining biotic and abiotic factor that determines the equilibrium state of the Earth system. And we have so much evidence of an ocean system under rapidly rising pressures. And the question is, are we even seeing signs of potential loss of resilience, meaning the buffering capacity of the entire Earth system and its ability to remain in the equilibrium interglacial basin of attraction that we have been privileged and dependent on since we left the last ice age some 18,000 years ago, and were able to develop civilizations as we know it in the Holocene, the Holocene ocean being a prerequisite for that development. Here we have the latest developments making us really concerned of our current trajectory. You see on the left-hand side, air temperature, the rise crashing through 1.5 degrees Celsius for the first time in 2024, and then the ocean surface temperatures following a same path. And what worries us is this accelerated warming trend we're seeing over the last decade, which for sea surface temperature is verified also from the data you see on the gray lines here from 2006 until 2022. This is the linear relationship between more climate forcing, more energy imbalance in the Earth system, and a linear increase in temperatures in the ocean. And then suddenly you have this jump, which is a very dramatic 0.3 degrees Celsius jump in only 1 year, in 2023-2024. Admittedly, an El Niño year with natural release of heat in the Pacific Ocean, but that cannot explain the entire jump. There has to be also anthropogenic forcing into the system, and that is verified not least by the dark, fat, black line you see there, which is actually 2025. which is entering a La Nina year, which you would have expected a settling back to the gray levels of warming. But we seem to be stuck at this higher level, which very likely has related forcing levels, but also Earth system feedbacks related to the ocean dynamics. One of them being the work published recently showing a decline in albedo over the northern hemisphere in particular, with less low altitude clouds, leading to more absorption of incoming heat from the sun. We also have the great work by Katrina von Schuckmann et al. Confirming the IPCC conclusions that 90% of the heat from fossil fuel burning and land use change is not in the atmosphere, it's in the ocean, and the rapidly rise of heat uptake, but also just the shocking quantifications that not only 90% of heat is hidden in the ocean, but also that 4% of the heat injection from fossil fuel-based burning and anthropogenic forcing is consumed in the transition of ice to liquid fresh water, concluding that only 1% of the energy imbalance on the planet's overall energy balance is in the atmosphere, causing the climate crisis and all the extreme events we're facing right now with fires, heat waves, droughts. The ocean is also showing a trend line of deoxygenation at levels that are starting to become a concern. We're also having more and more data on loss of species. We can talk of extinction levels being outside of anything we've seen in the recent geology. So the conclusion of a 6 mass extinction of species on land increasingly also applies in terms of loss of everything from mollusks to algae to fish populations across food webs in all ocean areas. We also have the dramatic observations of a fourth global prolonged bleaching event, which is now coming more and more frequently, with over 50% of the Great Barrier Reef very likely being on a permanent collapse pathway. We have the data on acidification in the ocean, which we all know is driven by the carbon dioxide buffering capacity. 25% of carbon dioxide from fossil fuel burning is absorbed in the ocean, a massive buffering and resilience capacity of the Earth system, but it also has the side effect of a 20% reduction in acidity, so higher acidity in the ocean, leading to degradation of calcium carbonate, and this is the data on the most sensitive of them, aragonite saturation state, which we use as one of the planetary boundary control variables, shown here in red, the ocean areas where we are also having the richest marine coral reef systems, subject to less and less favorable conditions for all forms of calcifying marine organisms. Sea level rise is something we've been concerned with for a long time. What we're seeing is also here a rate change, going from in the order of 0.2, 0.3 centimeters over decadal increase, and now jumping up to a level of 0.5, 0.6. And a reminder, looking at the paleoclimatic data, that last time we had a 2 degrees Celsius average temperature on Earth, we were at 2 to 6 meters higher sea level than the pre-industrial levels. So we're following a pathway that may take us beyond 1 meter by the end of this century. On top of all this, we also have that these linear trends of change are connected to tipping dynamics. And we have more and more science showing that changes in heat dynamics, in particular in the ocean, also connects between tipping point systems. So when the AMOC, the Atlantic Meridional Overturning Circulation, slows down, related to a very significant extent to the thermodynamic haline overturning system connected to higher cold freshwater release from the Arctic region and the Greenland ice sheet, that this slowdown pushes the monsoon systems further south, impacting on forest dieback in the Amazon basin, another tipping element system, which in turn also can explain why the West Antarctic ice sheet has a higher rate of melting because of a warming surface ocean in the Southern Ocean. We also have unknowns in this work. A lot of science right now looking at carbon sinks, not only from the abiotic solubility pump, but also from the biological carbon pump, which we increasingly understand, despite all the uncertainties, that it is in the order of gigaton uptake capacities per year. And the predictions are very uncertain of what will happen with the biological carbon pump under increased overfishing and increased heat in the ocean. But we cannot exclude that that is a system that may be starting to shift from a dampening capacity to self-reinforcing capacity. We also have the sea floor, which is a stock of over 2,000 gigatons of carbon, with the risks now of deep sea mining. What will happen if you start really harvesting the top layers of the sea floor? Trends of oceanic carbon storage, simply one of these unknown in the whole area. The AMOC, most observations indicate a slowdown of the AMOC, that we have a 15% slowdown, which can explain some of the dynamics we're seeing, not only in regional weather patterns, but also in changes in Southern Ocean dynamics. Is this something to be concerned about, despite the fact that uncertainties are high, likelihoods of a shutdown are low, but are not excluded? Well, for the simple reason that essentially all evidence shows that the AMOC has collapsed in the geological past, even over the past 1 million years. We also know that a collapse would have detrimental impacts across the entire planet. Accelerated rates of warming, changes in monsoon systems, abrupt shifts in life support systems in the Arctic region, shown in this dark blue cooling blob in the region. The planet as a whole would warm, but certain parts would cool. All of this leads to the conclusion that an AMOC collapse is an unacceptable catastrophic risk. So even if the likelihoods of a shutdown may be lower than 5%, it's still a likelihood or probability that is so high that multiplied by an infinite risk, infinite impact, would lead to an unacceptable risk. And that is where I think one has to also look at the ocean. If you list all the risks that I've just walked through of heat imbalance, rising rate of sea level rise, ocean acidification accelerating, bleaching events, deoxygenation, loss of species, and tipping point dynamics approaching, all of that leads to, despite the uncertainties, just to one conclusion. We have an urgency right on our watch, and we need to very rapidly protect the ocean, which is ultimately the fundamental regulator of the stability on planet Earth. So the transition is very fast. We have a pathway of exponential change required to have a safe landing within planetary boundaries. The planetary boundaries defining the Earth system processes that regulate the stability, the resilience, and life support on Earth. Among the 9 planetary boundaries, climate is one, ocean is a second, the stratospheric ozone layer, chemical pollution, but also the biosphere boundaries of biosphere integrity, which is all the living species that are connected to the biological carbon pump in the ocean, land system change, the whole bloodstream of the Earth system, the hydrological cycle, which is tightly coupled to evaporation dynamics in the ocean, and the overloading of biogeochemical flows of nitrogen and phosphorus, which in turn are fundamentally connected to dead zones in the ocean. So the ocean is ultimately connected as a web across all the 9 planetary boundaries. The safe operating space is now quantified. 6 of the 9 boundaries, that's what you see on this slide, have been transgressed. That confirms our concerns of an Earth system which is showing signs of losing resilience. The turnaround is urgent and has to happen quickly. We have then tried with expert elicitation and statistical analysis to bring all these 9 together into the first assessment of where is the planet's health positioned in a blood sample test equivalent. What you see here is in green, the safe operating space, the 2 lines of the uncertainty range in science. You see the box plot range in the white line, and we place the planet right at the edge of the danger zone, the uncertainty range in science, where things can go wrong, despite the fact that we are not entirely 100% sure. Go into the red zone, we have a higher likelihood, certainty of causing permanent, unstoppable change of the functioning of the Earth system. The conclusion here, therefore, is that we are in danger, indeed. We need a rapid turnaround, but the window is still open to be able to transition back within a safe, manageable future for humanity on Earth. Now, this also requires for us some changes in policies and governance. Scientifically, the planetary boundary framework has given us also evidence to suggest that we have to redefine the global commons. The global commons cannot only be the high seas, Antarctica, outer space, and the atmosphere, systems outside of national jurisdiction that are owned by nobody and therefore owned by all of us. We also need to include the scientifically defined tipping element systems in the Earth system, which are the biophysical systems that ultimately regulates the functioning of the Earth system. And here we see the AMOC, the coral reef systems, the West Antarctic ice sheet, of course, the big biomes on land, but also the big marine systems, that this is something that we collectively are responsible for and need to bring in to the governance of the whole Earth system. Thank you very much.
Thank you. And if you thought this would be a cheerful event, I think it's confirmed it won't.